Hello, I'm Brian Bowling from East High School.
I'm Sarah Lieber from Fairview Marguerite.
Candace Prophet, John Hay, 5th grade.
And we got to spend 4 days at Kawasaki here in Morristown, and it was a really great experience. So we're going to kind of go into the history of Kawasaki and how it got started. So in 1940 it was established in Japan, and they started making car jacks. So they kind of expanded from that since 1943. They got with Toyota, who is their largest supplier at this point. 70 to 80% of their industry, that's who they work with, is Toyota. Then in 2002, Kawasaki actually opened a plant here in Morristown, Tennessee. In 2003, the facility opened. Their first shipment took place in March of 2004. Then they expanded Plant 1. Then they purchased Plant 2. And I think they might be looking at combining those two buildings together possibly to expand again. And their mission is to strive to combine American and Japanese culture to create a unique culture where best global practices are fused together. And the one thing about Kawasaki, they bring a lot of Japanese work ethic into their program or into their industry, and they fuse those together. So the next slide we're going to kind of talk about is their the words that they use and how they take what they do in Japan and do it here in the States. So dojo, the way. So they do everything a specific way. They do it the same way at every station, and everybody's on the same page. So it's done perfectly. Ijo, something different. Poka yoke, making mistake proofing. And then Muda, the waste. They do not waste anything. They do not waste time. They do not waste material. They get out on the floor, excuse me, they get out on the floor with their employees, and they will time exactly what each employee does. And if they can take off 2 seconds off of that employee's walking, they will do that. So they do not like to waste anything.
The Kaizen, which means continuous improvement. Kai is Japanese for change or correct. Zen is good. This really struck a chord with me as a teacher. Many takeaways from this. This allows their employees to have a voice in what they're doing. Employees can do a Kaizen submission form. There's also a quarterly team leader scorecard that they use as their teams, and they create plans just to make things better. They evaluate problems. It's a problem solution way of doing things, and like I said, employees have a voice. I think it motivates their employees. It's a competition among the groups to come up with the best plans to improve things in their plants. Provides opportunities for success for everyone. We saw an example of one of the Kaizen plans, and I really felt like this employee, he was a hardworking guy, but I don't know if he would have kind of come out of his comfort zone without creating his plan, which he received recognition for. So the steps for making the continuous improvement that the employees go through, they plan their activity, they discuss the issues with the problem, they study current condition details, they create a goal, they list the causes, countermeasures, and results. And the whole time that I was looking at this, it reminded me of the scientific method that we teach students when we do scientific experiments. You can also relate this to math problem solving. This was just key for me to take away, to have students be better problem solvers, which also reminded me of the 5 whys. We heard a lot of that in the industry, going back to the root of the problem. After 22 years of teaching, I see a lot of blame. I see a lot of entitlement for my students, and I'm trying to get them to think a little more clearly on what is the problem. So this reminded me of that, whether it's in academics or behaviors or emotional issues. What's really the why? Let's go back to the root of the problem, the cause of the problem. What can we do to solve this?
Okay, so. Here we go. You know how to project? I don't think I was in here. Well, we had a video to show you, I don't know. I think it's on there. Do you know how to show me the screen? Oh, okay, yeah, do that. Okay.
And then
Thank you. Okay, so as this plays, we're going to talk about, this is the steps from after a product, they get the quote and they make the quote and they agree to make the product. This is the steps it takes to go from casting to machining to the finished product. And then we're going to talk through it and show you how at each step that we see skills that we're going to have to enforce in the classroom. So this is the furnace loader. This is an ingot has been put into the furnace and it melts to make the iron. So there's a job that someone has to load a furnace every day. 8 to 12 hours a day, that's what they do, is they load the ingots in the furnace. And a lot of times people don't see the big picture. They just see that you're a furnace loader. But we met a guy named Justin Reimer that started as a furnace loader, and they saw his quality and his work ethic, and then he moved up and now is working with the engineer in die casting. But he started as a furnace loader. So we really want our students to see the big picture and how it's a team. You have to work together and you're not always going to start at the top. And as it moves through, this is after it's trimmed, it goes next to an inspector. And what the inline inspector does is they take it after it's trimmed, they get it right off the conveyor, and they have to do an inspection. And they follow a standard when they inspect the parts. So what she's doing is she has to turn them a certain way, she has to look at them a certain angle, she has to flip it a certain way to check for impurities. So this is just paying attention to detail. If she does it her way, she might miss a part, and then that part gets sent off, and now it's a bad part, and Kawasaki looks bad. So as she's done it, she's really good at it. But she follows the standard, and just getting our students to pay attention to detail and why we have to do it a certain way. And this guy is he's doing this by hand. He's a hand machiner. So he is timed, and he has to load, can you go back just a little bit? Sorry, you're fine. From where he starts. So if he is late putting it in one spot, all of them are late. And then now he won't meet his quote because he's now behind. So he has to be ready, and this is initiative. This is enjoying what you do and understanding why I have to have this open at a certain point or I've missed the whole rotation. He's pretty fast at it. And then you have engineered machining. And this is where we met Brad Plumer, who was the engineer. And while we were walking through, there's a man that was there training another guy. And we asked everyone we meet, what was your degree? Did you go to CCAT? Did you go to a university? And the two men that we had met, one had spent 5 years at UT and just graduated with his engineering degree. And the other one was going back to Walter State, but didn't have a degree. And he had worked there 2 years, and he was training the guy that had the degree, because they saw, and he had started out, bottom of the line and worked his way up. And the engineering actually asked him to be on his team as an engineer, just to go back to get your degree. And he learned the how to do. And we asked the guy with the degree, he learned the methodology behind why he does it. So the guy that knows how to do it wants to go back to understand the method side of it, whereas the guy knows the method side, but he wants to know the how to do it. So it kind of goes together. Here's one. And the gauge checking, this is all math. This is your radius, your diameters. She's still following that standard, and she has to gauge check. This is after it's been casted and machined, and before it goes out. She's checking to make sure that the parts are right, the circles are the right diameter, and just everything works before they send it out. And then this is in quality. This is kind of like your machines are checking it, but you still have to know, like the